Hello everyone, it's Patrick from 8bitdoodads.com. Today we're going to be talking about SCSI. SCSI interfaces, SCSI drives, SCSI emulators, things that we use with our vintage computers, as SCSI was one of the first disk interface and even CD interface standards that were available for PCs, Apple IIs, Macintoshes, etc.
Say, kids, what time is it?
It's 8-bit doodads time!
Okay, first let's talk about SCSI drives. This was one of the early SCSI hard drives. This one was actually a 500 megabytes, so it's quite large, but some of the earliest SCSI hard drives were small. They might have been 20, 40 megabytes. What was available in MFM type drives at the time, those sizes were available. But as larger sizes came available, SCSI tended to have them first because SCSI not only got adopted by some of the early PC makers, they got adopted by server or workstation makers even more so. So sizes grew. And in fact, you can see a larger hard drive here. This is a 1.2 gigabyte SCSI drive. Now, these early drives had a 50-pin ribbon cable connector on them, and there's a standard power cable that connected to the SCSI controller. These two drives used that particular drive, that connector type, and that was one of the earliest. Later, and especially for servers, they came up with a new connector, which is this LVM or LMV 50 or what have you connector. This became very popular with RAID array SCSI drives and had even larger sizes. A small drive with this connector might have been 9 gigabytes. And I think they ended up, you could get 172. I don't know if they went past that because then SCSI and SAS, which is SCSI over serial attached SCSI, replaced it, and we have today the terabyte hard drives. The reason I bring this up is you can find these more readily available, especially on eBay. But they're a pain to connect unless you have one of those controller cards. And if you're interfacing to an old computer, you're not going to have this type of connector. So there are adapters that plug in that change this to the standard 50-pin connector, and there's additional adapter boards that plug in that give you that same conversion to the older standards. Last, I just want to show you on the hard drive front. This is a standard external SCSI drive that would have been at the time of the Apple II and original IBM PC series, or a Macintosh, the original Mac Plus, well, not a Mac Plus had a SCSI port, Mac SE, and the later ones started including SCSI ports, and this would allow you to plug a cable from here into that. One of the things you'll notice is there are two connectors on here, and in fact, this was one of the great benefits of SCSI. You can daisy chain drives, and in fact, in the original SCSI, you could have, quote, 8 devices, but it's really only 7 because the controller card counts as one itself, but you could daisy chain from one to another. And if you'll notice right here, there's little numbers, and I could press the up and down arrow keys, and there's numbers in there, and that changes this ID, the ID or SCSI ID of this device. And so each device had to have a different number on it. So if at the time you bought this, you bought 5 or 6 of them, you'd assign them different numbers, and you would have all of these hard drives available to you on the machine you are connected to. Some machines could support that more. On something like an Apple II, there's actually limitations on to how many volumes or partitions, if you might, that you could have mounted at the same time. So you might run into those limitations. But say on an IBM PC, this could be drive C, you could have a D, E, F, G, H. Also, with this same connector, they one of the first available CD drives that became available for PCs and others were SCSI based, and they had this type of connector on the back of those. There were other SCSI peripherals as well, like there were SCSI scanners that were made available, and in fact, I think Apple made one and used that high-speed bus for when scanning your document, transmitting that large amount of graphics from the scanner to the PC quickly. Okay, to work with SCSI hard drives, you needed to have an interface card in your machine. Apple IIs being my favorite vintage machine, I happen to know a little bit about the ones that are more about the ones that are available for that than the PC. There were hundreds of different SCSI cards made over the lifetime of the PC, and I have several of those, and they have different connectors. You notice on this particular one for the Apple, it uses a DB25. That's somewhat because of the case in an Apple. That's all the room you had to be able to plug this in out the back. And then what you would usually have is a DB25 to a Centronics parallel cable that plugged into that back of that external hard drive. One of the other things I'll mention about the SCSI external drives, you could chain them together, but one of the things you usually had to do is put a terminator, which was a little Centronics cable about that big that just plugged into the last free port that told it had reached the end of the chain. That's as SCSI sending the signal out the card, they're asking where all the drives are. They need the terminator pack said, I've gotten to the end. This is a typical PC card. Actually, this is one of the newer ones because this is not ISA bus, the original IBM PC bus, but PCIe. And this has both a 50-pin connector inside that would be inside the machine so that you could put a ribbon cable from this to internal drives, which would have been typically those 50-pin connectors like the drives I showed you earlier. But it also has that same DB5 connector on the outside so that you could plug into external drives. Now, I've seen these for both the original ISA bus in a PC that had DB25s, but also there have been some that had that Centronics port out the back, so you could use a 50-pin Centronics to go between the card and the machine. And the reason I brought these out is we're going to be talking about something called BlueSCSI, which is a SCSI emulator. And I actually happen to have a couple of them here. And you'll see this one has a DB25 connector. So you could take this and plug it right into the back, and that's your hard drive coming right off of this controller. And obviously it would plug into here as well. We also have those Centronics types. And so if I plugged this controller card into that external hard drive, I could then plug this into that second port on that external hard drive, and I'd have both my that hard drive and an emulated hard drive. And these use SD cards to store SCSI images, and in fact, these can emulate more than one SCSI device at the same time. So you could have a hard disk image on here that's at SCSI ID 3, 4, 5, 6, etc., giving you multiple SCSI images. Also want to show you, I just got this recently. This is Apple's high-speed SCSI card. This was the best one they made. There actually were a couple others that were even faster than this one. They had an original SCSI card, and then they came out with this one, which was, I think, like twice as fast as that one. But there's some others that had memory on them, and they did caching, and they executed the SCSI commands a lot better or faster, and they perform best. Now, we are talking about the 8-bit world, so it's not like today's machines with SSDs that, boot in seconds. This I just ordered. This is a remake And again, you'll see it has a ribbon cable with a DB25 again. This is a remake of a Surtec SCSI controller. And that's actually the SCSI chip there. And basically the ROM was mimicking the original ROM. This was an Apple II card. That was one of the more common SCSI controllers. And one of the nice things about this is it comes with software and utilities that allow it to work on the Apple with DOS, ProDOS, CPM, and Pascal. So it gave you all the operating systems that were available on the machine. You can see it's quite small. And ribbon cable just plugs in and gives you that same DB25 connector. I'm going to be interested to do a performance test down the road between these two to see which one's actually faster. The people who made this card also give you all the software you need and manuals and everything on here. The reason I got the card is we talked about this DB25 SCSI, and I said you could plug it into the IBM card, but on this card, one of the challenges is the Apple controller card doesn't supply what they call terminating power to a device. And what terminating power does is it actually gives you electrical flow into the device that powers the device. If you don't have that, then you got to use a external power supply to power this device with this card. The people who made this card just made an update, and I got the update. It now supplies that power. So I will be able to use this by just plugging it in. I won't need an external power supply or anything else, and I'll be good to go. The other reason we're doing this special on BlueSCSI is all these BlueSCSI units I have are what they call version 2. They came out with a version 3 that has some better characteristics, which I'm going to do something as a review between the 2 and the 3. But you'll see the ones I bought that were built previously use the Centronics and that DB25. Well, this time I got one that's that 50 pin, so this can go inside a machine. And I plan on using this inside a Macintosh to replace its spinning metal drive. And we also have yet another one of those DB25s and they do give you the case and everything to put this together. I thought it'd be interesting for you if you can actually see how these are built. So I'm going to turn this over to my partner on the channel, Greg, who's going to show you the building of these the two newest cards that we have, and then we'll come back and see them work.
All right, Patrick, thanks for the introduction. We're going to start with the small one first, then I'll jump over to the big one. They're both relatively easy, fairly beginner level soldering. Okay, I'm going to start with the DB25 connector. It snaps in. I guess it could snap in on the other side, but it goes on the top on this side. I've already tinned my chip because it's been a while since I've used it. Let's see what we got going on here. I like tapping in a couple of spots first and looking sure it's right where it needs to be, and it is. Okay, so I guess I forgot to hit record on that last little bit of soldering. It was all that along there. I've decided to put the short end of the pins down. I have the Pico in there to make sure the spacing is correct. I'm going to tack one corner of each. Then reheat and press up. There we go. There we go. Doesn't look pretty right now, but it will. Now this is not going to fit very well in this contraption, so I'm going to lay it down all the way and finish up the soldering, and this one will be done. Okay, sorry, I wasn't quite done. I still have to solder down the Pico. I'm going to try to keep a little space between the boards. I don't want to have to clip any pins, so I'm going to put down a couple of toothpicks. Keep the spacing even. All right, now I'm happy with the even spacing. Okay, let's get started on the second one. It's much bigger. It's got a few more components. It's got the SCSI connector here. Same pie. It might be a little different pie, I'm not sure. And it's got lots of different pin headers for various jumper settings. We'll find out when it's all done after I pass it back over to Patrick. I'm going to start with the SCSI connector again, and then I'm going to do the same thing with all the other pins, and I'm not even going to bother recording it until I get back to the end. Alright, just a quick note on this. Let me turn off my fume hood. This is also marked USB that direction, so that'll go down there. This has a power header and lots of other various headers, 2 and 3 pin ones. The power header is a 4-pin. I'm gonna go get back to work on it. And that is it. The second one. I wish I could get it to focus better. Well, it's done. Some beautiful soldering, if I do say so myself. Back over to you, Patrick.
Thank you, Greg. I really appreciate you helping me out with this project, doing the soldering, because as you know, I have no ability to solder. We're now going to test what he's done. And actually, this is one of the devices that he just soldered. This is the DB25 version. And as I mentioned earlier in the video, I had gotten a new SCSI card. And one of the benefits of this SCSI card over the Apple version is it can provide power to this device. So I want to check that out. So I'm going to install the SCSI card. And you can see in the case, I'm going to not install it all the way, just make this a little bit easier. And we'll plug this device right in here. Now, what I've already done is there's the micro SD card here. I plugged it into my PC with a USB adapter, and using CyberPress could create, it has the ability to read image files for hard drives, floppy drives, what have you, and I could actually make it create an image. So I used it to create an image with a bootable ProDOS system and put it on there, and we're going to power this system up and see if it works. And that's my Fast Ship 2E coming on. There's a quick look video on that. Be sure to stay tuned. And here you see a standard ProDOS got loaded. And we can come here and I'm going to go to Copy 2 Plus. which allows us to catalog a disk or what have you. And as you can see, this is working fine. So just on the first go round, and in fact, if we turn it over, I'll show you it is lit up. Now, the work on this emulator, the work of being a SCSI drive is with this Raspberry Pi Pico. That's doing all of the interpreting SCSI commands by reading the pins on here and acting to the SCSI card like it's a SCSI device. So it knows how to push the data back and forth. The rest of the card gives you logic and provides, with that SD card, it uses FAT or FAT32 to store data on it. And in this case, the data could be images. One of the nice things about this, about the BlueSCSI, is you can not only put one image on there, you can put as many images as SCSI will support. And in fact, I think you can create up to 6 images. And BlueSCSI now also supports the images not only being a floppy drive, actually they do a floppy drive, CD drive, and a hard drive. So it can emulate those different things. And with their newest firmware, one of the things I liked is you can create a folder for CDs and put a bunch of CDs in that folder, and they give you utilities. It will mount that CD. Now the Apple II, there is the option of having CD access on this, more so on the 2GS. But on the Macintosh, that becomes even more needed goal, where software might have come on CDs, or software installation for the operating system came on CDs. You could put a whole bunch of CDs in the folder. And in fact, the way they did the firmware, which is really clever, if you eject a CD, it automatically loads the next CD that's in that folder. So if you had multiple CDs and you're trying to install a bunch of software all at once, that becomes very handy. And I'm going to be doing another video on using these devices to upgrade or replace traditional spinning drives in a Macintosh. So stay tuned for that. I do have one correction. I kept saying earlier that the BlueSCSI version 2 and 3. It's actually version 1 and 2. This is a version 2 BlueSCSI. This is a version 1 BlueSCSI. The difference being some of the what's enhanced in the firmware. Also, I believe this one uses the Pico, and I'm going to take a look. This one uses a newer Pico than that one did, and in fact, you can see that they're different. But there's also some hardware differences and I believe speed differences. I'll do a deep dive into the BlueSCSI later. I just wanted to show from the start to the end of doing SCSI on the machine, we have it working. We're going to show this working later in a GS and on the Macintosh. And we're going to do some experiments with these on Macintoshes, especially this one, which is an internal hard drive emulator with that 50-pin connector, using the same Raspberry Pico device. One of the interesting differences, and I think it's because of the small size here, this uses the micro SD slot. This uses a full SD card. Not sure if there's really any differences in terms of capability, because you can now find memory card sizes up into the terabyte level for both of these. And oddly, I was shopping on Amazon recently to buy some more SD cards and micro SD cards for this. And for an Apple II or very early Mac, you really only needed megabytes or hundreds of megabytes would be sufficient, because an Apple II, for instance, can't support a volume bigger than 32 megabytes. So if you wanted to put 4 drives on at 32 megs each, you still only needed a 128 meg card. And the smallest card you can find today almost starts at 4 gigabytes. That's just an aside. But we will be experimenting with that. The other thing I want to do, I just give you a heads up on, is I mentioned earlier, this is the Apple high-speed SCSI card. This is the Surtec clone. The reason I use this, as I mentioned, is because it provides power to the card. If I use this card, I'm going to have to provide power externally. A power source that powers the board and the Pico, which is fine. There is a modification you can make to this card, but as I mentioned earlier, my soldering skills aren't that great. To make it do power over there, I don't think I want to abuse an original card like that. Lastly, I want to mention, we don't know what the performance is. That is a comparison I'm going to make. This card does support DMA, which makes it a little bit higher speed card. And as you notice, I mentioned when we booted up, I have my accelerator in here, and it fully worked, no problems at all. If you like this video, please click that thumbs up button and look for us on our channel, 8bitdoodads.com, and you can also on YouTube, 8bit doodads, and on Facebook, we have a Facebook group. Love to hear feedback from you, and especially if you had any thoughts on future videos we could do concerning Commodores, Apples, Ataris, Macintoshes, etc.